Souls designed an autonomous robot.
So this, we built a small scale, which is because of budget and time restrictions, we couldn't build a full scale. We attempted to, it just wouldn't work. It was much too big and too much engineering would have to go in it. We use the iRobot Create platform, which is an already built platform. We control it through our software. It's the same, it's like a Roomba. It's the same company, iRobot. So it goes right by itself, but we actually control our software and tell it where to go. And the camera on top here is what we actually use to do image detection.
So we use the camera to detect the leaves. Our algorithm right now for detecting mostly on the color, so we have it set so we got reds and yellows and orange. See something that's red and not a leaf that may pick it up. We have a couple other parameters such as size and stuff that hopefully we can turn from that. Originally what we wanted to do was see all the leaves in a frame and sort of get an idea of all the leaves in the area and then generate a path that would be the most efficient way to pick them all up in order to save battery life and do it most quickly. But as we tried implementing that, it turned out to be difficult and we realized there are some other factors like it may take a few seconds to calculate the path and then if the wind blows the leaves away, you lose the whole path.
I hate it when that happens.
So,
or you eat up more energy trying to determine how to save energy by...
Exactly. So, unless it's in a controlled environment, which it really wouldn't be most of the time, it may not be the best thing to do. So right now what it does is it just tries to find the closest leaf and pick it up like that, and when it sees no leaves, it will turn until it finds one and go pick that up. There's some other things we wanted to build in. Something obvious, boundary detection. You wouldn't want it to go into your neighbor's yard and start picking up his leaves and go on the street. We don't have that working well right now. And the other thing we almost had working, but again we don't, is for it to go back to a station to charge when it's on low battery. And along with that, we would try to do some sort of localization of the robot so it knows sort of where it is within your yard. And we figured for that to work well, sometimes yards aren't separated by anything identifiable. It could just be a line you might need to have a user enter something. And we really want to avoid that for this implementation. So that's what we're working right now.
That would probably just a problem to look at if we were to build a full-scale model, especially with like a GPS unit would probably be the best thing to do so the user could, ideally, they could see a map and tell it where to go and where not to go. Because we want to stay away from having to bury a wire. A lot of the robots today, or the dog things, you have to bury a wire all the way around your perimeter, which would essentially defeat the purpose of solving a lower back pain. So we want to stay away from that.
All right, so what we're going to show you is a quick representation of what we have in the poster here, the image filtering, how it detects the leaves.
The steps it goes through to actually get the 4 steps it goes through.
Yeah.
There's no keyboard.
So we have the original image, and what it does is it takes the original image and it blurs it. So when you blur it, it takes the average colors and it blends them together, so it makes it easier to process. So after that, we convert it to HSV color space because the light affects the image processing. And if you convert it to HSV color space, it's hue, saturation, value. So all you have to really change is the last one, because the hue is constant. And after you do that, run it through the function called the input. It's not the specific colors. It's matrix objects and combined colors. You see here, black and the white will detect. And after that, we had a boundary rectangle, so regular final leak detection.
Yeah, so here it is.
Yeah.
Right now you see it's just circling
Well,
this
I'm
leaf.
actually
That's
just switching jobs right now. So in my last week of engineering services, which is maintaining the current rides
This is it. Yeah, see, sometimes pictures are still stuff like that.
I'll show you the image you're seeing right now.
So this is what it looks like blurring for HSV color space. And the reason we didn't convert it to HSV is the way it normally displayed is VGR, which is it's a red value for every pixel on the screen. But when we use HSV, we can use just H, which is the hue, and we can just look for reds and yellows, and then the S&V or saturation value and brightness. So by using this color space, we can set the V value to a very large range, and that way lighting shouldn't affect it as much as it does, but because the camera we use, it does auto-adjust for lighting and color sometimes, and that's just built into the camera. There's nothing we can do with that in the software, so that, you know, it hurts a little bit, but ultimately the HSV color space is necessary for this, and it does work fairly well. Here's what it's seeing. I think we can just point the camera
This is how this is.
This is the stage it's at before we find boundary rectangles. So what it does is looks for edges, which is obviously really easy to do when it's just black and white. And then there's another thing where it will detect contours, which are slightly different than edges in that they're used to identify shapes. I guess. Once it has contours, which are different edges, because they're sort of connected to different shapes, then it can draw the rectangles. And every rectangle we consider leaf. So
It likes his orange shirt and red shoes.
yeah, that's what it is.
That's cool.
So what we're gonna do now is put it down for another thing. Try to pick
So
up
you're not doing anything to discriminate on shape. You can detect shape, but you're not acting on it.
well, it's hard to detect a specific shape. All these leaves are the same shape, obviously, but you could have different ones, and it's hard to tell it. Well, these are the exact edges on the leaf, and also you can see it's a really small window. This is a 1080p camera, which would be larger than this screen, but because it's running on the Intel Atom board, and the processor is not quite fast enough to handle all the image processing, we have to reduce the resolution down to something. I think it's like 500 by 300.
From those on the board, we have the times it takes to process at each resolution.
Yeah,
So we have to scale it down quite a bit to get it to one.
If we were running at the original resolution, the frame would take so long to refresh that the robot would just turn past the leaf.
This is a 2-minute warning. Presentation.
It leaves kind of look just like sun at some point. So there's no way to really tell that that's a leaf versus anything else in this resolution.
So the leaf versus that band, you know,
Further enough away, because of the resolution.
fair enough, was that?
I mean, I think there would be ways. For example, something we looked into was using something called a histogram to detect images. It's something we didn't have really a lot of experience with, so we didn't get a chance to try and implement and test, but it might be better off. We also tried template matching, so take a picture of the leaf, and if it sees that, the problem with that was it can only match a certain size. So if the picture was this big, if we looked for a leaf that big, it would be like 1,000 pictures of different sizes and scales plus for every leaf type, and it wasn't nearly as fast. So we found this was the best thing of what we were able to implement and try, and this would work. So yeah, the demo isn't going to show as many screens because that just saves up some processing time before the demo should try.
So it's plugged in right now.
We're going to unplug everything except for the keyboard just so we can tell it to stop. But if we unplug the keyboard, it will still
But you tried to make it. Right?
Tried, yeah, you tell one over.
works?
So another problem I don't think we saw here that it runs into sometimes is the way the Texas leaves is it just finds which one's closer to the bottom of the frame. And if you have two at relatively the same level, when it starts to turn towards one, the other one then becomes closer, and you just go back and forth. We have something in there that fixes it so that if there's two next to each other, it should just turn to one that's closer to the bottom and closer to the center. And most of the time that works, but sometimes it doesn't work correctly for one reason or another because the frames are refreshing multiple times per second, and sometimes a certain leaf may not get picked up, and then the next frame it will, just because where the camera's adjusting itself. And that does some problems with the stutters for but ultimately, most of the time, it's back into the right position, and it'll pick everything up. Eventually, that's pretty much all we have to do.
Very basic question. Does it have to be discrete leaves or it can be a bunch of
No, it can be bunches of leaves. What we do is, if they're close enough together, we just treat it as one.
Yeah, normally that'll pick up as many as it can, and if it doesn't pick them all up, it'll just see them again and pick up the smaller portion.
So yeah, if you had an entire yard covered with leaves, I mean, it wouldn't be that useful to have the camera because it would just go up and down, but it would basically stay on all the time if you got a lot.
And is there a feedback to how much you have picked up, how full you are, for example?
Actually, no, on this hardware model.
But I think that's not something we talked about.
Like I said, if we do a full-scale model, a lot of marketing more towards an add-on to existing systems. Like everyone has a contractor, so this would be a huge expense. You basically buy the camera, the computer add onto it. So it costs me really low compared to building an entire thing from scratch.
What year are you guys?
All software.
Oh, okay.
So you're controlling with the atom board, you're controlling turning on the blower, and do you drive the robot or does drive you?
Yeah, it's all done through the software.
What does design software?
Yeah, iRobot Create has an interface they come up with where you can give it directions to turn left or right. Also, you can turn on the lights and stuff, but that's the stuff we don't even use.
Is that RS-232 or RS-45?
And that's also what we're using for power the vacuum.
Yeah, they just have some digital I/O.
So is that a turtle bot?
Well, it's the same platform. It's the same thing. Yeah.
So open CBL?
CB.
CB, is that what you're using for your video analytics?
Yep.
So I think a lot of problems could have gone away had you used a simpler camera, right?
Yeah, I would have made something similar. Yeah. We didn't realize that at the time. We were testing this on laptops for it, it ran fine most of the time. Then we had to reduce the resolution, and that caused some problems.
Yeah, real world problems.
Yeah.
So, yeah, go ahead.
Oh, I was gonna say, so with the atom board, you're just basically doing all of this in software inside the.
Yep.
And you've tuned things so that you're limited to the performance because you're stuck with the atom, but you've tuned things to accommodate for that, right? So I like that you've shown that you had to dial that in and show okay, here's where we need to be.
So I guess that's kind of Have you considered offloading, like into the FPGA portion of this device?
Yeah, the thing
none
is,
of us had experience with that.
no experience in FPGAs, so we kind of stayed away from that. In a 6-month period, we don't think we'd be able to master like DSP or anything like that.
That is a bite to take.
That's a bite to take.
Yeah,
so,
we
you
did
know.
see stuff. You can't do we could have done all the image processing on the FPGA, but that was just.
And that would have made your
Much-
your signal processing much easier
Right,
because
yeah.
it would just crank through all that.
Right. Again, I think that was too much of a learning curve for the time period that
That
we
would
had.
be a lot of work.
Right.
Yep.
It's clean and simple, and I like that about it. I don't know why that's appealing. I mean, boom, right? You got it across. So I understand you were trying to do a bigger unit, and you came with what worked. And it's like,
Yeah, if we tried to do a full scale, we probably wouldn't have the working thing right now.
Oh, yeah.
So, it's too much.
Well, and the safety for a working model would be much more
Right,
difficult.
I mean,
to,
it's kind of already probably the demo in here anyway, so.
So while you're doing this project, is safety something that you considered? I mean, if you were putting this on your lawn tractor,
sucked
you're
up
gonna
a
be.
kitty cat, the neighbor's kitty
I
cat.
was thinking the neighbor's kid.
Yeah.
Yeah, that would be again more stuff we have to do with the full scale model, and obviously we have sensors for like this. You know, it has like foam sensors and stuff like that, but so we have different types of sensors. And we also
So if it runs into something, it'll stop.
1 minute left for Q&A.
this one, because we're not letting the iRobot run by itself, but we're controlling it.
So can you read the sensor that comes in?
It's like we have in the mode where it ignores collision and shifts and all that. It runs in a code because it has collision things on the front and the back is taped to it. It'll sometimes think it's just running into itself, and it's easier just to set it into a mode where we sort of that.
Right now, what is it running off? It has its own battery pack.
Yep.
Yeah. So
Was power a problem with this? Or do you have separate power supplies on all three devices?
There's actually separate power. This is because the vacuum and iRobot already had its own, so we just got one for the Atom board.
Okay, so that you're powering the Atom board separately?
Yeah.
when we get shipped here, it was built.
And that is it. All judges, please move on to the next booth.
Shipping, so all the wire was melted. So yeah, it's not as good as it looked before. So it kind of
Lucky you didn't go to jail over there.
Yeah, we are.